Hey, what's up, Logic fans? Welcome back to our third video on section 2.7, and I just wanted to put some final thoughts on this last argument we looked at. So, this is such an important topic, validity, and it's the big payoff for all of our legwork in Chapter 1 and Chapter 2, that I want to take our time with it and really explain things. So, we noted that the argument that had these three premises, A or B, if A then C, if B then D, and the conclusion C or D is in fact a valid argument. One thing that's kind of interesting here is that you can kind of get yourself to see intuitively that this is a valid argument. How is this a valid argument intuitively? Well, the first premise says either this first thing is true or the second thing is true. And then it's sort of like, okay, if the first thing happens, then this other thing happens, this third thing, C, happens. If this thing happens, the second thing, B, then this fourth thing occurs. So either the third or the fourth thing is going to occur, right? Like one of these two things is going to happen. If this one happens, then that happens. If this one happens, then that happens. So either of these will occur, possibly both. So from that perspective, intuitively, it's a valid argument. And this whole, truth table here proves that it is in fact a valid argument. Now, you're not always going to be able to look at an argument and sort of intuitively tell, particularly if you're a beginner, whether the argument is valid or invalid. But it is cool that in some of these cases you can see that, and it agrees with your intuitions, which reassures you that our logic is doing things correctly. Sometimes arguments are just so complex that you have no way of telling just by glancing at it if it's valid or not. Your intuitions aren't going to sort of go anywhere because it's just too complex. Fortunately, nowadays we've got these awesome computers that can tell us, even for very sophisticated arguments, whether they're valid or invalid, and they can tell us this very quickly. But we're going to be looking at comparatively simpler cases. Okay, let's take a look at an argument where you might have to do a little bit of work in the truth table before you can figure things out. Let me show you an example like that. Okay, so just to give you a simple example of what I have in mind, let's suppose that you're looking at this argument. So is this argument valid or is it invalid? And you might have to do a little bit of work before you can show it. Pause now and we'll come back together and do it. So in this particular case, the premise, it's only got the one premise, which makes your life a little bit easier, but it's a little bit harder because it's, you want to build up to the premise. So let's just say we had like A or B here, and then we had, it's not the case that A or B right here. So we're going to go like this roughly. All right. In other words, we're not just going straight to the premises and the conclusion. Instead, we're actually just sort of building up to the first premise. And sometimes you have to do a little bit of grunt work before you can do that, okay? Like here. So this isn't an actual premise, right? Premise is right here. But we're sort of breaking the premise down until we can see clearly what the premise is. So we've got the premise here, and then we've got the conclusion here. So sometimes there's a lot of sort of grunt work that has to take place in between, and that's okay. Let's go through this together really quickly, okay? Again, you've got the two propositional constants, therefore 4 possible assignments, and if it's valid, every assignment that makes all the premises true is also going to make the conclusion true. If it's invalid, there's going to be at least one case, one assignment, that is, where all the premises are true and the conclusion is false. So A or B is just going to be our truth table for wedge. If we negate that, we're going to get this, and then B goes true, false, so not B is going to go false, true, right? And there's our truth table for this argument. Let's inspect it. Is there any case where all the premises are true? And yeah, there is one such case. That's this case, right? Here's a case where, in other words, here's an assignment where A is true and B is false, and in that assignment, the one and only premise is true, and therefore all premises are true. And so we've got to make sure that the conclusion is also true on that assignment, and indeed it is, since no other cases have no other assignments have all premises true. It turns out that this is in fact a valid argument. Okay, and I just wanted to illustrate that sometimes you got to break the premises down and even the conclusion down before you can line up your premises and your conclusion all together. And if that's the case, then you just need to do that work. Okay, so this is in fact a valid argument. Okay, I want to jump into a couple of special features of validity. It has some subtle aspects, and I want to make sure that those are very, very explicit to you, because the definition of validity, shall we say, doesn't wear some of these special features of validity on its sleeve. Okay, so by way of making these special, perhaps even counterintuitive features of validity explicit, let's go through this. So here's a claim. If an argument has a conclusion that's a tautology, right, so its conclusion is logically true, then that argument is valid. Is that true or is that false? Pause now. Okay, this is true. Any argument that has a conclusion with a tautology is going to be valid, okay? And this is a straightforward aspect of the definition of validity. So let's try to think about this a little bit. All right, so suppose I've got my truth table for some argument. It's got premises 1, 2, up to and including premise n. So maybe it's got 10,000 premises, maybe it's only got 3 premises, who knows? And it's also got a conclusion c, okay? Now here's what we know. The argument's conclusion is a tautology. So every single one of these, however many there are, okay, I'm just going to illustrate it this way. However many, these are all true. Now, the definition of validity says, all right, in every case where all the premises are true, the conclusion is also true. In every assignment, right, in every one of these rows where all the premises are true, the conclusion is also true. So no matter how many of these you have with all true premises, okay, the conclusion is also going to be true, and therefore the definition of validity is going to be satisfied, okay? So you could think of validity, right, if we think about it this way, as saying if all premises are true, then the conclusion is true, right? It's something like that, right? Okay. Well, let's think about this for 1 second. So the definition of validity is a conditional. Here's its antecedent, here's its consequent, right? Now, if the conclusion is true, which it will be if the conclusion is a tautology, it's logically true, it's going to be true all the way down, right? So the conclusion is true, that means that you've got the consequent of this conditional here being true, and therefore the conditional is true, right? That's one way of thinking about it, okay? And so, in other words, the definition of validity is satisfied. This is the definition. The definition is a conditional. That conditional holds whenever the conclusion is a tautology. Another way of thinking about it is that there can never be a case, so looking at it from the perspective of invalidity, there can never be a case where all the premises are true and the conclusion is false. There can never be a case where all the premises are true and the conclusion is false if the argument's conclusion is a tautology. Right? So this is absolutely true. If an argument's conclusion is a tautology, then that argument is valid. All right. Here's another thing. This is kind of interesting. So let's try a slightly different one here. So let's do, if an argument, let's do it this way. If an argument has a contradiction for a premise, then it is valid. Is that true or is that false? So what do you think of that claim? Pause now. Okay, this claim, all right, I hope you had a chance to think about it, is also true. Right, this is also true. So let's suppose that one of the premises, and maybe multiple of them, but at least one of them was a contradiction. That means it's going to go false all the way down, okay? Again, thinking about this from the perspective of invalidity, to be invalid, the argument has to have at least one case where all the premises are true and the conclusion is false. Well, if one of the premises is a contradiction, you're never going to have all the premises true, namely the one that's a contradiction, right? You're never going to have all the premises true and the conclusion false. So the definition of invalidity is not satisfied, and therefore the argument is valid, right? These are mutually exclusive and mutually exhaustive features of arguments. So another way of thinking about it is, if all the premises are true, well, that can never happen if one of the premises is a contradiction. So this antecedent here is false. But if you have a false antecedent, you have a true conditional. In other words, the definition of validity is satisfied. It's another way of thinking about it. So you can approach this from different angles, but the big point is that this is true. Okay. And again, these are sort of special features of validity, and I want to unpack them for you because they're not obvious. Let's do another one. And I suppose I'm just going to sort of show you this one. It might be a little brutal to write out, but the idea is that suppose you never have a case where all the premises are true. I guess we could just do this as a sort of, corollary to two here that we just did. Suppose that you never have a case where all the premises are true. Well, if you never have a case where all the premises are true, the argument is valid. So let me type that in here. If no assignment makes all of the premises true, then the argument is valid. Okay, and this is absolutely true. All right, this is absolutely the case. If no assignment makes all of the premises true, as would be the case if one of the premises was a contradiction, for example, that's not the only way it can happen, but it's one way it could happen, then the argument is valid, right? It has to be, right? Because think about it again from the perspective of invalidity. To be invalid, there has to be at least one case where all the premises are true and the conclusion is false. Okay? And that can never occur if no assignment makes all the premises true. Okay? And so another way of thinking about it, if this never happens, if there's never an assignment where all the premises are true, then this antecedent here ends up being false. False antecedent, true conditional. This is the definition of validity. So that would be valid. This is a true statement. Okay, so take the time to really think about that and understand that. Again, it's a subtle, counterintuitive feature of validity, and it does absolutely follow from the definition of validity, but as I say, it's subtle, and so I'm trying to make it explicit for you. I hope that helps. Okay, I'm going to cut to one final video, 2.7D, where we're just going to look at some very common, historically interesting and important valid argument forms. Okay, so I want to talk about that notion a little bit. See you on 2.7D.